Well, hello, everybody, and welcome. I'm glad you're here. Hey, I've got a calculus problem here that I think is pretty fun. It's kind of cool. Here's what the instructions say. They say to find the intersection of the normals to the curve, y equals 2x squared plus 3x plus 1, at the values of x equals -1 and x equals 3. So why don't you go ahead and take a crack at that on your own. See if you can figure this one out. And here in just a minute, I'm going to try it myself. Are you ready? All right, here we go. I'm going to dive into it. Try it on your own first. All right. Now, I think that the best thing to do with something like this is to visualize exactly what it is you're looking for. Make sense of the question before diving in and doing any what I would call random active math, right? So it says find the intersection of the normals to the curve, and it gives the equation and 2 points. Well, the intersection is going to be where two lines cross. So we're looking for a coordinate x comma y, and normals to the curve, well, those are perpendicular to the tangent line at the points x equals 1 and x equals 3. Now, the curve, well, because we have a degree of 2, it's quadratic. It's going to look something like this. And at x equals -1, we're going to have a tangent line, right? We're going to figure out its slope. The normal line is perpendicular, so we're going to take the negative reciprocal, right? And we're going to do the same exact thing at x equals 3. We're going to figure out what the slope is over there. Then we're going to write an equation for each line and see where they cross. And our goal is to figure out exactly where they cross. Now, the reason I decided to make a video about this problem is because I think it's often the case, especially in the beginning of a calculus class, that the calculus itself isn't that tricky. It's actually the algebra that's a little tricky. And here, none of this is difficult. Every single step is easy, but it's easy to get lost. So it's really important exercise it's really important to be able to visualize, and I thought this was a good exercise to practice exactly that. All right? So now we have a visual of what we're going to do, so let's strategize. Let's make a plan, right? All right, so we're going to find the equation of each line, the normal line 1 and the normal line 2, and we're going to set them equal to each other and see where they cross. So let's go ahead and start by finding the first one. All right, now we have to figure out either 2 points or a point and a slope if we want to write the equation of this line right here. All right, so the slope, well, that's where the calculus comes in. We're going to take the derivative of 2x squared plus 3x plus 1. That's the derivative is going to give us the formula that will find the slope of this curve at any value of x. So we're going to just use the power rule, right? So we're going to get 4x plus 3. That is the derivative. So all we got to do now to figure out what the slope at -1 is plug in -1 for x, and we're going to get -1. -4 plus 3, -1. All right, now our point. To figure out the point right here, we have to take that -1 and we have to plug it in to the original function. We can't plug it into the derivative. That just gives us the slope. We want to find the y coordinate. So we take that -1, plug it into the original equation, and we're going to find out that at -1, y is equal to 0, and our slope is -1. All right, so now that's our information right there, but we're looking for the normal line, which is going to be perpendicular to the tangent. So instead of using a slope of -1, our slope is actually +1. All right, now equation of line is y equals mx plus b. We could use the point slope formula, but why do that if you don't need to? I think it's a lot easier just to use y equals mx plus b, plug in our values for y, m, and x, and solve for b, just like this, and we're going to see that b is equal to 1. So our equation is y equals x plus 1. That's the first normal to the curve at x equals -1. Now let's do the same thing for x equals 3. All right, let's find the slope at 3 by plugging in 3 into the derivative. So we're going to get 12 plus 3, which is 15. So the slope of the tangent line is 15, which means our normal line is going to be a slope of -1/15. All right, the point, we're going to just take 3, plug it in, and we're going to get 28. So our coordinate is 328. And a slope that we're going to be using is -1/15. So just like before, starting with y equals mx plus b, I've got a little fraction to deal with, but that's not a big deal, right? We're going to figure out that b is equal to 28 1/5. So the equation of the second normal to the curve, y equals -1/15 x plus 28 1/5. So we have to figure out where those two cross. The way to do that, algebraically anyway, is set them equal to each other. right? So x minus 1 equals negative 1/15 x plus 28 and 1/5. Let's go ahead and get the x's together on one side and the other numbers, just the numbers themselves on the other. So 1/15 plus 1 is 16/15, and 28 minus 28 1/5 minus 1, well, let's change those into some mixed numbers or improper fractions, and 136 over 5. That's what we get. All right, multiplying both sides by the reciprocal, just doing a little bit of reducing, or we could just use a calculator for the whole thing. Either way, it doesn't really matter. We're going to get 25.5 or 51 over 2 for the x coordinate. Now, the reason I pulled this x plus 1 over here is we know what x is. We got to figure out y, and I would much rather plug a number into x plus 1 than into this thing. So just adding 1 to 51 over 2, we get 26.5. So our coordinate where those two lines cross, where the intersection of the normals to the curve at x equals -1 and x equals 3 is 25.5 and 26.5. I think that's a pretty cool problem. And I think that the calculus itself was really easy. We just had to find the derivative and use it. But I think it was a good a good exercise to practice, because it forces you to make sure you understand what the derivative is doing, what the equations are doing, what the original function is doing, and all of that kind of stuff all together at once without a step-by-step guide. It's just you figuring it out. So I thought it was a cool problem. I hope you did too. If you did, give me a thumbs up, like, subscribe, comment, share, all that kind of cool stuff. And until next time, I hope you have a great day.